The problem of finding the tangent line to a graph is one of the motivating problems of differential calculus. We've already seen how useful tangent lines can be. Primarily, this is because linear functions are easy. They're easy to compute because all you have to do is multiply and add. They're easy to understand. There's not much to say about a linear function. Its graph is a line. Things are pretty straightforward. And finally, this won't be too important to us, but it's worth noting, linear functions are easy to solve equations with. If you have a linear function equals a value or a linear function equals another linear function, this is the easiest kind of equation you could imagine. You just have to subtract and divide and you can solve the equation. So the idea is going to be to leverage that easiness of linear functions to understand other functions. In fact, we've already seen this. On day one, we saw that sometimes the function we need to model a situation with, probably most of the time the function we need to model a situation, isn't going to be linear. Sometimes we have to use functions that involve square roots, that involve trig functions, maybe exponential functions. There's all sorts of functions out there that are very useful, but are somewhat harder to understand than the linear functions are. And the idea is a function and its tangent line are close enough that we can get away with it. Here, I've displayed the tangent line to this graph at x equals c. That's going to be a line that passes through the point c f of c and just touches the graph. Okay, but how do we do that? In fact, what does that even mean? One way to describe a line is the point-slope form, which requires us to know the slope of the line and also a point on the line. The point is easy to find because we are interested in a line that passes through c f of c. Question, how do we find the slope? The answer is to take an approximation. So what we're going to do, instead of finding the tangent line itself, we're going to find a nearby line, a line that has a similar slope. We do that by picking 2 points. So we pick 2 points